Hello students, in today's session of Semiconductor Universal, basics will be cleared through circuit diagram to identify forward biasing, reverse biasing, find R equivalent, current drawn, etc., which are going to be very useful for CBSE plus 2 boards, state boards, JEE mains, UT, NEET, other examinations. In earlier sessions, we have gone through. This week, you can review on YouTube channel sethiswiftlearn. As the session is going to be very important for beginners, so it is requested go through the session completely. Now let's start with the question. Question is, in figure, assuming the diodes to be ideal. By going through this figure, we have to take one correct answer out of the 4 options available. This is a diode, this is also diode. Minus 10 volt is applied here. This is grounded. Grounded means earth, grounded or earth, you can say 0 volt, right? Now, concept applicable in solution. One is forward biasing of junction diode, one is reverse biasing of junction diode. Diode is represented by this sign. If positive is there, negative is there, that is forward bias. If negative is there, positive is there, that is reverse bias. Ideally, forward bias conduction is allowed. In this case, no conduction. Ideally, open circuit. Ideally, open circuit. Right? This is P-type. This is P-type. In P-type, one is there are 2 types of conductors, semiconductors: intrinsic and extrinsic. Silicon and germanium belong to group 14. Tetravalent. In this case, it is a pure form of semiconductor. Extrinsic, some impurities added. Some impurities added means either from 13th group, that is trivalent. Trivalent means either from aluminum, boron or aluminum. It becomes P-type. If impurity is added from 15th group, that is pentavalent, and that is phosphorus or arsenic. Then it is the N-type. In this case, majority carriers are electrons. So if this is P-type, this is N-type. In this case, majority carriers are holes. These are electrons. Forward bias, P connected with the positive term, N-type connected, that is the forward biasing. In this case, majority carriers move toward the junction. In this case, majority carriers move toward the junction. This is the forward bias. And depletion region, effect of forward bias depletion region decreases, right? And reverse of that is, in this case, majority carriers, this is the reverse bias, P with N-type and N with positive terminal. This is the reverse bias. Depletion region increases, and in this case, this is P-type. Majority carriers move away from the junction. In this case, move away from the junction. In this case, move towards the junction. Both the majority carriers move the way. Now, come to the question. D1 is forward bias and D2 is reverse bias. So D1 is reverse bias, correct. And D2 is forward bias. This is 0, this is minus 10. So this is, then D2 is forward bias. This is correct. D1 is reverse bias, and no current flows from B to A. No current flows from B to A. It is forward bias, current will flow from here to here, but because this is an open circuit, so no current will flow. It will not a closed circuit, it is open circuit. So therefore, option B is the correct option. Option B is correct option, right? Next question. Question is, which of the following circuits is reverse bias? Answer is very simple. It can be given within 15 seconds, but before giving the answer, certain concepts will be cleared. What is forward bias? What is reverse bias? It will be discussed again. If P-type is connected with the positive terminal, N-type is connected with the negative terminal, that is the forward bias. If reverse is there, that is P-type semiconductor is connected with the negative terminal and this is connected with the positive terminal. In this case, majority के errors, P-type में majority के errors holes हैं, इसमें electrons हैं. Majority के errors move towards the junction and depletion region is decreased. In this case, majority के errors moves away from the junction. In this case also, in this case also, and depletion region is increased. Forward bias, this should be higher, this should be lower. Forward bias, if lower, this is higher than reverse bias. If higher, lower, this is reverse. This is the basic concept, right? Now, in this case, this is higher, this is lower, this is forward bias. This is higher, this is lower, this is forward bias. This is higher, this is lower, this is forward bias. This is higher, this is lower, so this is reverse bias. So option D is correct. Option D is correct. Out of 4 figures, D option is correct, which is reverse bias, right? Next question. Question is, the value of net resistance of the network as shown in the figure, given figure is. After going through this network, we have to conclude one of the correct answers here out of 4 options. Concept, applicability, and solution. Forward bias, this is higher voltage, this is lower voltage. Forward bias, just like short circuit, ideally. Simple wire. If it is lower voltage, this is a higher voltage. Then this is reverse bias. Open circuit, ideally. Open circuit, ideally. It allows the conduction, it does not allow the conduction. Now in this case, minus 6 volt, minus 8 volt. So this is higher voltage. This is the lower voltage. So this is higher voltage, so this is forward bias. This is reverse bias. So this circuit reduces to like this. This will allow the conduction, this will allow the conduction, this will behave like open circuit. So total net resistance will be between this. This is 1510. 15 ohm, 10 ohm. So R net will be equal to parallel to the product upon sum 15 to 10 upon 15 plus 10. That is 150 divided by 25. That is 6 ohm is the answer. Let us see the answer. 6 ohm. A option is correct. A option is correct. Right. Next question. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE main, JEE advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video discussions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल सेटिस्विफ्ट लर्न सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट and share with your colleagues and friends. Now let's start with the question. Question is, reading of the ammeter for the silicon diode the given circuit is this. 4 options are given to you. One of the options is correct. Now, concept applicable in solution. In the given question, ideal diodes are not mentioned. Ideal diodes are not mentioned. We have to consider potential barrier. Potential barrier. We have to consider potential barrier. For silicon, 0.7 volt, and for germanium, 0.3 volt. These are the potential barrier. Now, as this positive is connected with the other, this is forward bias. So this circuit can be reduced to as conduction is being allowed. This is 0.7 volt, this is 3 volt. This is 200 ohm. So I will be equal to net EMF divided by the applied net EMF the resistance. So net EMF will be positive and negative 3 minus 0.7 divided by 200. On simplification, 2.3 divided by 200. On simplification, this comes out to be D option. D option is the correct option. Right? Next question. Question is, each diode shown in the figure has a resistance of 25 ohm in forward bias condition and infinite resistance in reverse bias condition. What will be the values of current I1, I2, I3 and I4? Concept applicable in solution. Forward bias and reverse bias. In this case, if it is forward bias, 25 ohm resistance will be offered. If it is reverse bias, this will be like an open circuit. So, according to the figure, this is forward bias, this is reverse bias, this is forward bias. So, I3 will be equal to 0, I3 will be equal to 0. And I2 will be, this circuit can be redrawn. This is I1, this is I2, this is I4. This is 25 ohm, this is 25 ohm, this is 125 ohm, this is 125 ohm, and this is 25 ohm. So I1 will be equal to applied EMF. This applied EMF is 5 volt. 5 divided by the equivalent circuit, equivalent resistance. Equivalent resistance will be 150 parallel 150. 75 plus 25. This comes out to be 100 ohm. So this comes out to 0.05 ampere. I1 will be equal to 0.505 ampere. 0.05 ampere. Because these are the symmetrical, I4 will be 0.025 ampere and I4, this is I3 will be equal to 0, I2 will be equal to 0.025 ampere. These are the answers. Because in this case, this is symmetrical, it will be divided equally. Otherwise, we know the case of division. R1, R2, I1, I2, I. I1 will be equal to R2 over R1 plus R2 into I, and I2 will be equal to R2 upon R1 plus R2 into I. You can apply this concept, right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept clearing videos. Thank you.